In this video, we'll be solving an AP Precalculus Unit 3 mock exam together. This mock consists of 20 questions, 19 multiple choice and 1 FRQ. All are AP style. Um, it should not take more than 90 minutes for us to solve together. It could be earlier as well. Calculator is not allowed, by the way, so yeah, no technology. I encourage you to participate and solve the questions as we move along, and probably you can type in your answers in the chat box as well. And if you have any doubts as we move along, uh, please make sure to post it in the comment section, and I'll try to check it periodically. All right, so let's move ahead with our first question. All right. So this one suggests that this one says that we have in the xy plane we have two different angles, alpha and beta, and they're asking that if they are in the standard position and they share a terminal ray, then based on this information, which are the following is possible values of alpha and beta. So what is the meaning of this, sharing a terminal ray? What exactly do they mean from? Don't you think that's a funky way of saying that these are coterminal angles? And when are two angles coterminal? When the difference between them is, or if you want to understand it in the other way, let's say I have an angle over here and I want to make a coterminal angle. So a coterminal angle to this could be when I move by 360 degrees and come back to the same position, right? And what if I move another 360 degree? I will again come back to the same position. What if I move 360 degree on the other side? Again come back to the same position. So in other words, I want to say that two angles are coterminal when the difference between them is either 360 or a multiple of 360. So n is an integer over here. If you want to understand this in radian world, it could be 2 pi n, where n is again an integer, which can be positive and negative both, of course. Okay, so all we have to do is take the difference of all these four options and see which one is giving us something like this. So if I say alpha minus beta, let's talk about option A. So that's negative pi over 2 minus pi over 2, right? Negative pi over 2 minus pi over 2. And this is just negative pi, which is not what I want because I want it to be 2 pi, not pi, right? If you talk about option B, it is negative pi over 2 minus 3 pi over 2. Be careful with the double negatives here. So negative pi over 2 plus 3 pi over 2, which is going to be 2 pi over 2, which is again going to be pi. Not interested, rejected. Let's talk about option C. Option C is pi over 2 minus 3 pi over 2. I think we have a winner. This is pi over 2 plus 3 pi over 2. And this is 4 pi over 2. And 4 pi over 2 is just 2 pi. So that's our answer. That's what we want, right? 2 pi or a multiple of 2 pi. So our answer is option C. Hope this makes sense. Let's move on to the next question. This figure shows a circle centered at the origin with an angle measured theta in the standard position whose terminal ray intersects the circle at point P. This is P over here. And the equation of the line is given. The equation of the line is y equal to negative 4 over 3x. And that is in quadrant 2. Okay. This portion is in quadrant 2. Okay, so which of the following is true about theta? So they are interested in getting either the value of cosine theta or tangent of theta. Okay, how can we do that? So although I do not know the coordinates of P, but I know that P lies on this line. So if the x coordinate of P is just x, can we say that the y coordinate will be negative 4 over 3x, right? Because y is just negative 4/3 of x. So if we have this, then we can easily find the value of tan theta, because tan theta is easiest actually. We know that tan theta is just y coordinate over x coordinate, right? What is the y coordinate? It is negative 4 over 3x. And what is the x coordinate? It is x over here. x and x is gone, so we are just left with negative 4 over 3. So that should be the tan theta. Is that in the options? Yes, indeed. So that is option D. We don't even have to talk about cosine. So yeah, that is option D. All right. Over here, we are given a graph of sinusoidal function, and the graph of g can be written as sine theta plus d. We have to find out that what is the value, what are the values of the constants a and d in this case. All right. I think D is the easiest to find because D is just the midline, and the midline is something that I can just see, right? Isn't this the midline? This is the line that is passing right through the middle. So this is definitely the midline, which is represented by D, and I can just say that that's -2. So I know that the answer has to be either A or C. DS2 doesn't make any sense. Then we talk about A. A is, ideally, absolute value of A is the amplitude. So I can definitely find what the amplitude is, right? Because this is the midline and this is the maximum. So distance between the maximum and the midline is the amplitude, which is 2 units. But I cannot just blindly say that the answer is A equal to 2, because remember that the sign decides where the sign, as in the plus or minus, decides whether the sinusoidal curve is going up or down, right? Fortunately, in this case, when the sine curve starts from the midline, it is actually climbing, right, going up, which is similar to the parent function because parent sine also looks like this. So now I can safely say that the value of A is 2 and not -2, because had it was -2, the curve will look like this. It will be exactly flipped about the midline because it is now going down. Why? Because A is -2. So that's why don't be carried away just by the number A, just because it is amplitude. Remember, amplitude is always absolute value of A, but A, the coefficient can actually be negative. So be careful about that. Okay, so in this case, it is positive because it's going up. So the answer is just C. Right. Over here, the figure shows the graph of the trigonometric function f, which of the following could be an expression for f. Okay. For me, I personally feel that finding B is the easiest, although it will only help me to rule out. I mean, if we are lucky, maybe 4 is not the answer, and only option A is correct, which makes by default. But yeah, finding B is actually okay. When I talk about B, I mean to say A sine B x minus C plus D. So A sine B x minus C plus D, where I have this B is 2 pi over period. So for me, that looks pretty easy to find because I can just figure out what the period is pretty easily. It starts from here. I'm taking this as the starting point, and it goes all the way till this point, right? Goes all the way till this point. I have to stop here because this is where one cycle is completed. So I started from 0, went all the way to pi over 2. So I think the period is pi over 2. So 2 pi over pi over 2. Yes. I'm going to use keep change flip. 2 pi divided by pi over 2. And 2 pi divided by pi over 2 is keep change flip. So these two are gone and I'm left with 4. So unfortunately, the value of B is 4, not 2. So option A is definitely wrong. And I'm left with B, C, and D. Then B, C, and D, the midline is same in all of them, right? It's -5. I can also just see it. So, well, that's not going to help us. Now, what can help us is whether A is positive or negative and what is the horizontal shift. Okay. Ideally, actually, I just see that the sine curve looks very usual because it starts from the midline and it's climbing, right? So, an easiest way to write the sinusoidal function would have been if A is just 15. Why 15? Why not -15? Because it's going up. So, um, um, it's going up, so it should be positive. So 15 sine B value is 4. I'm not seeing any horizontal shift because it's just starting from c equal to 0. So it's 4x, and the midline is just minus 5, right? Okay, so in this case, this is 15 sine 4x minus 5, but this is obviously not in the option. So what can be another way to write this, this sinusoidal function? Maybe I can look for some shifts over here. If I'm talking about, let's say, pi over 4, which I can see over here, I think that could make sense because minus pi over 4 would mean that the curve has been shifted to the right by pi over 4 units, correct? Because minus means horizontal translation to the right. And amplitude, as in, not amplitude, the a value should also be negative. Why negative? Why not positive? Because it is going down if I take this as the starting point, right? So that's why, although this is absolutely correct, if you type this in Desmos and you type in option B, both will give you the exact same answer. But since they're trying to trick us and not giving us the, a direct answer or very intuitive answer, which is the boxed one, uh, the modified version of this is option B. C and D will not work, guys. You can try it out, but if you're, let's say, doing pi over 2 shift, you cannot go negative 15 because at pi over 2, the curve is going up, right? So that will not work. And likewise, option D is also not going to work. All right, okay. So let's talk about question 5 now. In question 5, we have, okay, they're talking about something that is going on between 0 and pi over 2. Between 0 and pi over 2, I think this is the portion, right? And in this portion, they are asking that what is happening with the function? Is that increasing, decreasing, increasing rate, decreasing rate? Okay. I think increasing, decreasing is still not that bad to figure out because we can see that it is going down, right? It is descending in nature. So it makes sense that our answer has to be option C or D because the function is decreasing in nature. So that's definitely should not be a confusion. But when they talk about rate, remember that's a fancy way of saying concavity, right? If they're talking about increasing rate, it means concave up or smiling phase function. And if they are talking about decreasing rate, they are talking about concave down, which is frowning phase function. And this is clearly a smiling phase function. So we are going to say that this has increasing rate. So the answer has to be option C. Does that make sense? I hope it does. Any questions? Feel free to let me know. Okay. Let's talk about question 6, just asking us to simplify this expression, which is cos x over 1 plus sine x plus tan x. So you have to remember identities over here because it's used pretty aggressively in all such questions. So over here, I think I'm not really comfortable having a sine, cos, and tan actually in the first place. I mean, 3 trig functions, it gets a little difficult to handle. So I am thinking to replace tan with sine and cos, sine over cos. This is the reciprocal identity, right? I want to add these two, so I would like the denominators to be equal. So I will multiply and divide the first guy with cos x, and I'll multiply and divide this thing with 1 plus sine x. Okay. So over here, I will now have a common denominator. So the denominator is common. It looks like cos x multiplied with 1 plus sine x. Cos x times cos x is cos square x, and sin x times 1 plus sin x is, sin x times 1 is just sin x, and sin x times sin x is sin square x over here. Okay. What is cos square x plus sine square x? That's a pretty popular Pythagorean identity. Sine square x plus cos square x is 1, so I'm just going to replace that with 1. The other sine x remains as it is, I mean to say this one. And this cos x remains as it is, and this 1 plus sine x also remains as it is. And don't you think that these two are gone now? And we are just left with 1 over cosine of x, and 1 over cosine is just secant of x. And that is indeed in the options, so the correct option is option C. Okay. Here we are looking to find the inverse of this particular function. So what is the procedure for that? It doesn't really matter whether the inverse is actually of a function that involves sine curve or exponential or logarithms or polynomials. The procedure is same, that if fx, the first step is just fx is just y, right? So we rewrite this as y is equal to 9 sine x minus 3. Remember that it is not sine x minus 3, it is sine of x minus 3. Okay. The next step is to replace x with y and y with x. So I'm going to replace y with x. I'm going to replace x with y over here, so sine of y. And now our job is to isolate this y. Okay, so I think I'm going to add 3 both the sides. So if I do that, I will have x plus 3 is equal to 9 sine y, 9 sine y over here. If I have 9 sine y, I want to isolate y, right? So let's flip the omelette actually. Let's put 9 sine y over on the left side and x plus 3 on the right side. And now I can divide both sides with 9. So it's going to look like x plus 3 over 9. And I want to isolate y. So I'm just going to say that y is equal to sine inverse x plus 3 over 9. And finally, this y is replaced with inverse symbol of the function. So f inverse x is equal to sine inverse x plus 3 over 9. So that is the final answer, which matches with option B, right? Okay. Okay, this is about solving trigonometric equations. So here they are saying that find all the solutions of the, okay, this involves a double angle. The moment you see sine of 2x or cosine of 2x, it is definitely about the double angle identities. And in my opinion, these are important. So please make sure you memorize this eventually if you have not done it by this time. So sine of 2x is 2 sine x cos x. Right off the bat, I'm going to replace it like that. And this sine x remains as it is, and this is equal to 0. From here, I can take sine as a common factor. So sine is taken out. I'm left with 2 cos x plus 1 is equal to 0. And then I'm going to say that sine x is 0. Sine x is 0, because I'm just using the 0 product property, right? If the product of two things is 0, then it means that either the first thing is 0 or the second thing is 0. So either sine x is 0 from here, or 2 cos x plus 1 is equal to 0. Okay, when is sine 0? Now this is all about unit circle. Sine is 0 whenever x is 0, x is pi, x is 2 pi, 3 pi, negative pi, negative 2 pi, and so on. But remember that our answers should only be between 0 and 2 pi. So I'm not really interested in, or let's say I'm only interested in 0 and pi. 2 pi is also in parentheses, so that is not included. So I'm not really interested in these. So from here, I'm getting two answers, 0 and pi, right? Then I have 2 cos x plus 1 is equal to 0, which means that 2 cos x is equal to negative 1, which means that cos x is equal to negative 1 over 2. Okay, cos x is negative 1 over 2. Cos is negative actually in which two quadrants? It's in quadrant 3, sorry. quadrant 2 and quadrant 3. Because if you remember, we have an acronym of all students take calculus. So this C of calculus corresponds to cos. So in quadrant 1, we know that all trig functions are positive, and in quadrant 4, only cosine is positive. So we are talking about cosine to be negative, which happens in quadrant 2 and quadrant 3. Okay. Um, so what is the reference angle for, okay, there are two ways to answer it. If you remember the unit circle pretty well, you can just think of the quadrant 2 and quadrant 3 angles where the cosine is negative 1 over 2. Or the way I do is, I just think about the reference angle, which is basically the angle when cosine of x is just 1 over 2, as in I ignore the sign over here. And cosine is 1 over 2 when x is pi over 6. I'm sorry, pi over 3. Cos 60 degrees, 1 over 2. And pi over 3 can easily be switched or, converted into its respective quadrant 2 and quadrant 3 angles by doing quadrant 2 as pi minus the reference angle, which is pi over 3. And quadrant 3 will be pi plus the reference angle, which is pi plus pi over 3. So this is going to be 2 pi over 3, and this is going to be 4 pi over 3 over here. So this is how it looks like. So I have two more answers from here, 2 pi over 3 and 4 pi over 3. So 0 pi, 2 pi. Okay, option C, I think. Option C has all the four answers. So yeah, option C is the correct choice. Does that make sense? I hope it does. Okay, help on 3.6b worksheet. Is that not already on the channel? I think 3.6b should be, because entire unit 3 is already on the channel. It should be there, I think 3.6b, but yeah, let me know if 3.6b is not there. Okay, let's try the next question. This is question 9. This is about polar curves now. Okay. Determine which point on the polar graph is represented by the given polar coordinate. So we have 4 points P, Q, R, S, and we need to find that -4, -pi over 2 correspond to which of the point. Okay, my recommendation is this negative sign always creates confusion. So just ignore that negative sign for the moment and graph 4, -pi over 2. Right. So in other words, graph with positive r, right? With positive r. Now 4, -pi over 2 is where negative, whenever angle is negative, by the way, please always remember that we are going clockwise, right? Clockwise. Counterclockwise is when the angle is positive. And if the angle is negative, you start going, sorry, did I say clockwise? I meant counterclockwise. Counterclockwise is when the angle is positive, and clockwise when the angle is negative. Here the angle is negative, so I have to go clockwise, and that too by 90 degrees or pi over 2. So obviously 90-degree ends over here, or in other words, this is just the 90-degree. Let me just make that symbol. This is 90-degree over here. So I will, and 4 means 4 units, right? So this is 1, 2, 3, sorry, this is 1, this is 1, this is 2, this is 3, this is 4. Would have been R had the point was this. But since we are looking for -4, -pi over 2, all you have to do is swing this point 180 degree. So if you swing this point 180 degree, it goes right on the other side, which is point P. So our answer should be P over here. That should be our answer, right? Okay, this is a pretty interesting question. Given a polar function r equal to f theta, the distance between f theta and the origin can be determined by comparing the sign of the r value and the function's behavior. which of the following statements is true? So if f theta is increasing and r is positive, then the distance from the origin is increasing. If s theta is decreasing and r is negative, I'm not sure if the question actually, as of now, makes sense to you. But okay, let me first simplify the scenario. They are just pretty much asking that if there's a polar function, then just by knowing whether f theta is increasing and decreasing and r is positive or negative, how can I know whether the distance from the origin is increasing or decreasing and so on? So my recommendation is graph this in actually rectangular plane, right? Graph it in the rectangular plane. This will be very, very easy for you. Let me do that. This is the rectangular coordinate. Okay, there are two things that you have to understand for the rectangular coordinates. If you're talking, if you are doing a polar equivalent in the rectangular form, you need to understand that r is positive whenever the function is above the x-axis and r is negative whenever the function is below the x-axis. So these are, this is one thing, and the other thing I'll just explain as I solve this question. Now, we very well know what increasing function is, right? So if I have to make an increasing function with a positive r, and I already told you that the positive r is above the x-axis, don't you think that the function should look like this or should look like this, something like this, right? So this is case one, where the function is increasing, climbing, of course, and r is positive, right? Now, what is the distance from the origin? When we talk about the rectangular plane, the distance from the origin is basically the height from the x-axis. This height from the x-axis is actually the distance from the origin. So if the distance from the origin, is the distance from the x-axis increasing here? Yes, definitely it is. It is increasing. So if the distance from the x-axis is increasing, we can definitely say that the distance from the origin is also increasing. It has to increase, right? So option one is absolutely correct. Let's try again the same situation with option two. Maybe it will make more sense to you. If f is decreasing and r is negative, okay guys, r is negative where? I already told you r is negative below the x-axis in the rectangular plane, and it is decreasing. Decreasing means obviously going sort of like this. Now, is the distance from the origin, from the x-axis increasing or decreasing? I'm pretty sure it is increasing because look at these vertical bars. The heights are increasing, right? And if if these heights are increasing, it means that the distance from the origin also is increasing. So 2 is absolutely correct as well. And if we talk about this one where f theta is decreasing and r is positive here, and if I want to decrease f theta, it should look sort of like this. In this case, is the height from the x-axis increasing or decreasing? Well, I'm pretty sure it's decreasing. And they are saying that the distance from the origin is increasing. No, absolutely not. So option 3 is definitely wrong, but option 1 and 2 are the option A is definitely correct. So 1 and 2 are absolutely correct. I hope this makes sense. This was slightly tricky, but yeah, if you actually try to understand this by graphing on the rectangular plane, I think it should make some better sense to you. All right, guys, if you're finding this mock helpful so far, please consider please consider to like, subscribe, or probably share it as well, so it could reach other students. All right, let's talk about vertical asymptotes. Now, this is again something important. In fact, knowing the conditions for the vertical asymptotes of tan, cot, secant, and cosecant. Sinusoidal curve doesn't have vertical asymptotes, right? We know that. So don't worry about that. But for these, you have to know what is the condition for the VAs. Okay, at the moment, I can definitely tell you that the condition for tan, which I'm going to tell you here, is going to be same as secant. Both conditions, both have same conditions. And the condition for cotangent and cosecant, that is also same. So even if you remember one, you can actually, in a way, you're remembering actually two already. All right, so that's how it works. So whenever I have uh, tan, the condition that I'm looking for is the inside guy, and I don't really care how complicated or fancy the inside guy is. I always try to remember it as the inside guy. When I say inside guy, I want to say that A tan B x plus C or x minus C plus D. When I say inside guy, I'm talking about this entire thing, right? So this thing should be equal to, in our case, this is pi x. So pi x should be equal to pi over 2 plus k pi, right? This is the condition for the vertical asymptote for the tan functions. And of course, this condition is also for the secant functions as well. So and if you agree, I cannot divide both sides. Okay, I can do one step for you so that you understand this. So I'm going to take pi out as a common factor. So this will be 1 over 2 plus k. Now, I think it will make sense that if I cross these pi's out, so I think I have my answer, right? X is equal to 1 over 2 plus k. That should be the final answer. And yes, fortunately, this is in the option. So correct choice is option C. Any questions so far, guys? We have done 11 questions. Is everything making sense, or do you want me to go back to a particular question and probably explain it again? I can do that. Okay, all right. The next question talks about the graph of tan function. Okay, they're saying that h is given by tan of b times x plus c, and we need to look for the values of b and c. Like I said earlier in the sinusoidal curves as well, finding b is pretty straightforward because there's a formula for b. But remember, this formula is different than the sinusoidal the curves, sinusoidal curves, or in fact cosecant or cotangent curves. There, the formula is 2 pi over period. Here, the formula is pi over period. And that formula is applicable for tan and cot as well. Um, so you have to remember this about the tan and cot. So what is the period over here? If we see what is the one cycle, I think this is one cycle, right? This entire piece is one cycle. And I'm starting from 0 and I'm going all the way to 2 pi. So the period has to be 2 pi. So I'm going to divide this with 2 pi, and pi over 2 pi is just 1 over 2. So the value of b is 1/2. So option A or B, that should be our answer. Okay. What about this one? C value. So C value just tells us the horizontal shift with respect to the parent function. And we know that the parent function passes through the origin. So I can see that actually this function can be, we can think about this function as either moving right by pi units or actually left by pi units. Both could work. So C value can be pi, or C value can also be minus pi. In fact, both works. Well, negative pi is not an option. Pi is definitely an option in A and B. Definitely not pi over 2. Pi over 2 doesn't make any sense because otherwise there will be pi over 2 here, which is definitely not something that we see. So it has to be pi or minus pi. Pi is not in the option, so we're going to go with pi. All right, let's move ahead to this one. This is a pretty interesting question. It's also slightly tricky. In this function, we are given f and g, and we need to find that where do these guys intersect. So intersection means that fx should be equal to gx, right? That is the meaning of intersection. So fx is 1/4 of tan inverse of x over 3, and gx is pi over 6. I multiply both sides with 4. So tan inverse x over 3 should be equal to 4 times pi over 6, which also means that tan inverse x over 3 is equal to 2 pi over 3. Now at this point, we are tempted just to take tan both the sides, and x over 3 is equal to tan of 2 pi over 3. We can find tan of 2 pi over 3, multiply 3 both the sides, that's our answer. But no, this is a trick question, because can tan inverse actually be 2 pi over 3 in the first place? Ask ourselves, what is the range of tan inverse? Tan inverse is always between negative pi over 2 and pi over 2. It can never return a value that is greater than pi over 2. Pi over 2 is 90 degree and 2 pi over 3 is 120 degree. How can tan inverse ever be equal to 120 degrees? So there is actually no such value for which these two will ever intersect, because this is beyond the domain, beyond the range of tan inverse, right? Yeah, so the answer for this one is option B. Okay. Well, secant question. We already talked about this in a way, because we talked about tangent, and the condition for secant and tangent are same for the vertical asymptote. The condition for the vertical asymptote was the inside thing should be equal to pi over 2 plus k pi. So I'm going to say that this is equal to pi over 2 plus k pi. I'm going to multiply 3 both the sides. Okay, students make a mistake that when they multiply 3 both the sides, they will just say 3 pi over 2 plus k pi. No, it should be 3 pi over 2 plus 3k pi, because the 3 is getting multiplied to all of them. This is the generalized solution. But of course, if we put k as 0, remember k is integer. K is integer over here. And if we put k as 0, then the value of x comes out as 3 pi over 2, which is definitely one of the options. Option D is the correct choice over here. Okay. All right, switching to polar functions now. So we are given the value, the equation of a polar function, that is 1.5 plus 1.5 cosine of theta. And we have to find that which of the following is actually the correct graph of this. Okay, I'm going to give you a pro tip over here. Whenever you see a cosine, a polar function with cosine in it, whether that's this is called cardioid. Again, the name is not important; it doesn't really matter even if you know the name or not. But even if you are seeing something like this having a cosine, or something like cos of 4 theta, or something like cos theta, in fact, anything of the cosine with a cosine in it, its orientation is always going to be horizontal. What do I mean to say when that the orientation is horizontal? You see these 4 options. This is more oriented towards the vertical side, right? And this is oriented rather towards the horizontal side. Now that's what I mean to say when it will be oriented towards the horizontal side. So it cannot be option A and B right off the bat, because it is a cosine. It has to be a horizontal orientation. All I need to think of is whether it is option C or option D. So that's when you can just put in a very easy number instead of theta. Just put theta as 0. So the value of R, or f of theta, will be equal to 1.5 plus 1.5 cosine of 0. Cosine of 0 is 1. 1.5 times 1 is obviously 1.5. 1.5 plus 1.5 is 3. So the value of R comes out as 3 over here. Where is 3? This is definitely not 3, because this goes on the other side. I'm talking about theta equal to 0. And at theta equal to 0, I'm talking about this angle. And at this angle, r is 3 over here, right here. This is 3 when angle is 180 degree. So that doesn't make sense, right? I'm just putting theta as 0, not 180. So at 0, it is 3 in option C. So option C is the best choice in this case. Okay. Over here, we are given that which of the following equation is, again, the polar curve. The moment I see horizontal orientation, this is horizontal orientation, right? It has to be a cosine curve. So it cannot be sine right off the bat removed. R equal to 4 is a circle. I think you know this. That's simply straightforward polar curve. R equal to 4, or maybe a generalization R equal to A. This is a circle. This is definitely not a circle, so option C is ruled out. This is called a rose petal curve, and the number of petals, if they are even, if we count the number of petals, it will be 8. 1, 2, 3, 4, 5, 6, 7, 8. If there are even petals, then the neighbor of theta, which is over here, will be exactly half of the number of petals. So since the number of petals are 8, the neighbor is going to be 4, which is in both the cases. Now, in order to rule one out of these two, again, my suggestion is to put theta as 0. If I put theta as 0 and b, it is going to look like 4 plus 4 cosine of 0. Cosine 0 is 1. 1 times 4 is 4. 4 plus 4 is 8. Well, I don't really see 8 anywhere on this curve because it ends at 4, right? This is 4. This is the maxed out value for R actually. So it's just definitely not B. And if I just put theta as 0 here, this will just be 4 cos 0, and 4 cos 0 is 1. So it is option D. That's what you're talking about here. That should be the correct answer. Okay. The figure shows the polar curve over here, which is 6 sine 2 theta. And there are 4 points labeled A, B, C, D, E. Just in case if you cannot see E, E is right here at the origin. They are saying that if we restrict the domain between 7 pi over 4 to 2 pi, then which of the following portion of the graph is actually that remains? So the first one is the top portion in quadrant 2 from E to A. E to A is this in quadrant 2. And likewise, there are 3 other options. So they are saying which one is something that is, left in the curve. This is slightly tricky, but once again, my recommendation is to graph this on a rectangular plane. And if we do that, this question will actually be a lot manageable. Okay, let's see how to graph 6 sine 2 theta. What is the period of sine 2 theta? It will be 2 pi over the coefficient of theta, which is just 2. So it's 2 pi over 2. That is going, that is going to be the period, which is just pi over here. And the sine, it's the usual sine curve, right? No horizontal or vertical translation. So the sine curve is going to just look like this. Okay. What is the period of this? This is pi. So this is where one period ends. And my recommendation, I'll give you a very good trick to mark these other points as well. Whenever you get the period, divide the period in 4 pieces. So pi divided by 4. And this pi over 4 will actually be the markings over here. For example, this maxima will be pi over 4. Now this point will be pi over 4 plus pi over 4, which is 2 pi over 4. I know 2 pi over 4 is pi over 2, but I prefer to write as 2 pi over 4 because the calculation will be easy. The next point, which is the minima, is going to be 3 pi over 4. And the next point will be 4 pi over 4, which is anyway pi. We know it is pi. Then the next point will be 5 pi over 4. Why am I going all the way? Because they are asking us till 2 pi, right? But I'm only at pi, so I have to mark these points. 5 pi over 4, 6 pi over 4, 7 pi over 4, and 8 pi over 4. And 8 pi over 4 is, of course, just 2 pi. So now I know that they are talking about 7 pi over 4, which is right here, and 2 pi, which is also right here. So this is the portion that they are talking about. Okay, I already told you that the R value, when it is at the bottom, below the x-axis, is actually negative. So here R value is negative. And what is the quadrant of this, guys, by the way? 7 pi over 4 to 2 pi. Isn't that quadrant 4? Because it is very, very close to 2 pi. So this is in quadrant 4. Now tell me, if I graph a polar curve in quadrant 4, but I make its R negative, don't you think that it is going to actually swing exactly 180-degree to quadrant 2? Isn't that making sense? Because that's what we do in the negative R, right? If you remember, we did one question or this PQRS thing. Where's that? There you go. That's what I did. I made R as negative R and switched this 180-degree, right? That's what I'm saying here, that if you are graphing something in quadrant 4, and in quadrant 4, if then you are making R as negative, it has to switch or swing exactly 180 degrees. So it will be in quadrant 2 now. That is for sure that the answer cannot be in quadrant 4. So C and D are ruled out. And now tell me, is the R value, is the height increasing or decreasing? Isn't that clearly decreasing? So it is coming towards the origin, or I can say towards the pole. And if we look at the options, option A is saying it is from E to A, and E to A I have already highlighted. It is going away from the pole, right? Clearly away from the pole or the origin. It is going clearly away from the origin. That's not what I want. I want it to come towards the origin. So the answer has to be option B. Option B, where it says that it is from A to E. A is here, E is here. It is in quadrant 2 as well. So it is definitely coming towards the origin, because the height is clearly decreasing, as we have seen over here, right? Okay. Let's talk about question number 18. Here they are saying that this one is a polar function, and which of the following in quadrant 2, because the R is negative in the last question, that's what happens. If you have seen the last question where I did P, Q, R, and S, that's a property that if you are graphing a point which is R comma theta, and then you are graphing negative R comma theta, it actually swings by 180 degree. That's a property. If you don't know it, probably now you know. And that's how I said that originally it was in quadrant 4. Let me go back to the question. Originally it was in quadrant 4 because that's where the angle is. And now if it goes to quadrant 2, why? Because this is R is negative and it goes exactly 180 degree opposite to it. Right, I hope that makes sense now. Okay, on which of the following intervals is the distance between the polar coordinate and the origin decreasing? So that's basically the same question they are asking us. So I'm just going to graph this on the rectangular plane now. I know that the time period is 2 pi, by the way. I don't have to worry about that. No funky stuff going on. Midline is 2, right? Can we agree on that? Midline is 2. So there you go. I have 2 here. What is the maximum value of this? The maximum value, actually, you know what? I prefer to rewrite this as -4 sine theta plus 2. And I don't know if you know this formula. If we are given A sine B theta plus C plus D, although the maximum minimum honestly is irrelevant in this question, but I'm just still covering this because it will be helpful for you. The maximum value of this is going to be absolute value of A plus D, and the minimum value is going to be negative absolute value of A plus D. So in this case, the absolute value of A is going to be 4. 4 plus 2 is going to be the maximum, which is 6. There you go. And the minimum value will be negative of 4 plus 2, which is negative 2. So negative 2 is right here. And there are other ways to find maximum and minimum as well. This is not the only way, by the way. Okay, there's no horizontal shift, so that's good for us. So it definitely starts from here, but be careful. It doesn't go up. Why? Because A is negative. Whenever the leading coefficient, not the leading coefficient, sorry. Whenever the neighbor of sign is negative, it has to start downwards because it is going exactly opposite to compared to its parent, right? And the parent goes up, so it will go down. And what are the points, by the way? Again, I told you the trick. First find the period. The period is 2 pi, and then divide 2 pi in 4 equal pieces. So 2 pi divided by 4 is just 2 pi over 4. I know that 2 pi over 4 can be simplified to pi over 2. You can also do that. But again, I am not going to do that because it makes the calculation slightly difficult. So I'm just going to write this as 2 pi over 4. Then 4 pi over 4, and then 6 pi over 4, and then 8 pi over 4 is just, 2 pi. So at 2 pi over 4, it's going to hit the minima. At 4 pi over 4, midline, 6 pi over 4, maxima, and then 2 pi again, the midline. So it's going to go like this, then this, then this, then this. All right. Now they are saying that which of the following options is correct, and I want the height to decrease, right? I want the height to decrease. Pi over 6 to pi over 2. This is pi over 2. I'll just simplify these numbers now. This is pi over 2, this is pi, and this is 3 pi over 2. Till pi over 2, I don't really think so, because when you are approaching from pi over 6, I don't know where pi over 6 is, maybe here, maybe here. It doesn't really matter, because ultimately you are approaching pi over 2. And if you are approaching pi over 2, obviously the height is clearly increasing, right? But we clearly stated that we need the height to be decreasing. So this is not decreasing, this is increasing. So that's not it. If you're going from 5 pi over 6 to pi is right here. Again, I don't really know whether 5 pi over 6 is here or here. I don't even want to find, because if I approach till pi is here. Again, the height from the x-axis is increasing over here, right? And I don't want increasing, and I want it to be decreasing. So B is also not correct. Likewise, let's work on C. C is saying that 5 pi over 4 to 3 pi over 2. 3 pi over 2 is right here. Same situation. If I'm going towards 3 pi over 2, the height from the x-axis is increasing, right? So that won't work. It has to be D, which is going from 5 pi over 3 to 11 pi over 6. 11 pi over 6 is somewhere over here. 5 pi over 6, 5 pi over 3 is somewhere over here. Why? How do I know that? Because it has to be more than 3 pi over 2, right? Both these people are in quadrant 4, and this is quadrant 4 already. So I know for a fact that in between these two, the height is definitely decreasing, and that's what I want, right? It should decrease, so the answer is option D. That should be our final answer for this one. Okay. The last multiple choice here says that in this polar curve, which is graphed from 0 to 2 pi, there are no holes, and it passes through each point exactly once as theta increases. And it is actually moving in this order, from A to B to C to D. So it is moving in this order with the increasing theta. They are saying that in which of the following case is the AROC least? So first of all, what is the formula for the AROC in the case of polar curves? AROC is given by f theta 2 minus f theta 1 over theta 2 minus theta 1. When we are, from some angle theta 1 to some angle theta 2, this is how the AROC is given. So you don't really have to look for the coordinates. There is a trick over here, because f theta is what? After all, it's r value, right? So can I write this as r2 minus r1 over theta 2 minus theta 1 after all? So this is how the r value looks like. So AROC, sorry, this is how the AROC looks like. Now look from A to B. Don't you think A to B, the R value is actually same? Like this distance and this distance, it's symmetric. It's same. And I don't really know what the theta 2 and theta 1 are. It is in the increasing order, so I know theta 2 minus theta 1 will give me some positive number. But I don't really care because R2 and R1 are both same in the case of A and B. So don't you think that AROC is just going to be 0 in case A? So for case A, it is just 0. Let's talk about B to C. From B to C, I can clearly say that C, the length of C, as in the R value at C, is greater than B. And theta 2 minus theta 1 is always positive because they clearly said that these are passing in this order as the theta is increasing. Right, so I know that C minus B angle is always positive, so I'm not bothered about angle. And in this case, R2 minus R1 is also positive because the R of C is greater than B. So this is a positive number. Likewise, B to D, there is no difference in B to D. In B to D also the same situation because C and D are the same R value. So in this case also, it is same as B to C case, it is positive. D to A, now D to A, something interesting is going to happen because D is at a longer R value and A has a shorter R value. And it is always R2 minus R1. So we will take R of A and subtract R of D, which is going to be a negative number. So this is negative. And they're asking that which one is least. Obviously, the one with negative is the least. So it has to be option D. All right. Let's work on the last question. That is an FRQ. There's a FRQ over here. They're saying that there is a bumpy amusement park ride and in which there is a cart that moves up and down periodically as it travels along a wave-like track. The cart takes 6 seconds to complete one full up and down motion. So that's just a fancy way of saying that the period is 6 seconds. Okay. If the period over here is 6 seconds, then what else do they have to tell us? At the highest point, the cart is 50. So I know that the maxima is 50. And the minima, lowest point, is 30. So that's also given in the question. They're saying that assuming that the ride starts exactly between the highest and the lowest points. That's a fancy way of saying it starts at the midline. And the midline is nothing but the average of maximum and minimum value. So 30 plus 50 over 2, which is 80 over 2, which is 40 feet over here. That's where it starts. All right. So they are saying that if this graph shows 2 cycles of this function, it is not necessarily, I mean, the bottom line is not necessarily the x-axis, right? It can be any axis. So they are asking us to determine the possible coordinates of all these points. Okay, all such cases, and this is, by the way, going to appear as FRQ 3 in the AP Precalculus exam. My recommendation, work for the y values first because it is very easy. I know that the maximum is 50 and f is the maximum. So I will talk about the time later, but I can mark that the maximum coordinates are 50. The midline is at 40. So G is also at 40 and J is at the minimum, that is 30, right? So I'm going to mark this as 30 over here. So that's how it's going to work. At least for the y coordinates, is pretty straightforward. Now, to find the x coordinate or the time, it is very important to see where that situation starts from. In other words, at t equal to 0, where was it? and I can clearly see that the right starts exactly in between. So right starts probably at G. We can assume that the right starts at G. So G, we are tempted to say that the T of G should be 0. But that won't work, because if T is 0, then F will go with a negative time, right? And unfortunately, they are nowhere mentioning that this is Back to the Future 2 kind of situation, right? So we cannot have a time traveling situation with a negative time. So we cannot take G as 0. So what is the next time at which the point will again be at G? Don't you think that will be the period of the function? Because the period is the time after which it comes back to the same point. Now, I'm not saying that it is mandatory for it to be 6. It can be 12 as well. Maybe after 2 cycles, it came back to the same position. Maybe it's 18. I mean, pick your choice, whatever you want, that's correct. But I would personally want numbers to be less, so I will just take as 6. Now, for the other points, again, follow the same strategy that I gave you earlier, that take the time period for sinusoidal functions, take the time period, divide by 4, divide it in 4 pieces. So 6 over 4 in this case is 3 over 2, which is just 1.5. Why divide in 4 pieces? Because this 1.5 will actually be the time between these phases, F to G, G to J, J to K, and K to P. So these 4 phases are actually differ by 1.5 seconds. So it becomes so easy, because I know that this is at 6, G is at 6. I'm going back, so I have to subtract 1.5. So 6 minus 1.5 is 4.5. I'm at G, I'm going at J, I have to add 1.5. So 6 plus 1.5 is 7.5. So this is over here is 7.5. I'm going forward, again 1.5, 9, again 1.5, 10.5. So these are one possible set of the coordinates of this scenario. There can be multiple coordinates, of course, but this is the one possibility. Okay. Now they're asking that if that guy is written in this form, then what is the value of A, B, C, D? I think D is the easiest to figure out, because D is the midline, and I already have the midline as 40, as you can see over here. So I'm just gonna mark quickly D as 40. Next easy thing is the period. So B value, which is given by 2 pi over period, and the period is already given in the question as 6 seconds, right? So I'm just going to mark B as 2 pi over 6, which is just pi over 3. Okay. So I have these two numbers now. Now, A and actually C sort of go together, because there can be multiple possibilities. For example, if I know that the A has to be either plus 10 or minus 10, right? Because this is the height between midline and the maximum. It has to be either 10 or minus 10. But if I'm taking, and I know that I have to look at the point where it is at midline, because that's when the sign starts. That's where the sign starts. So you have 2 options, or actually literally not 2 options. You have various options, but 2 easy options that I see over here. Let me first actually write what we have so far. So I have sine of pi over 3 of t, and something will come here, and then plus d value, right? So something will come here and something will come here. Now, the first option is you consider G as the point where it is, starting from. So first off, in G, what is the horizontal translation? Isn't that 6 units? 6 units to the right or left? Right. So if I'm going right, I will do t minus 6 over here. And this is, by the way, 10 already we discussed. The only question is whether that's plus 10 or minus 10. If you're writing this, it has to be minus, no doubt, because at G, the curve is going downward, right? It's going opposite. So this is one possibility. If you are not a big fan of a negative a, you can write positive a, positive 10, sine pi over 3, something will come here, plus 40. But in that case, you have to make t as your reference or starting position, sort of. Because at k, it is although going up, but the horizontal translation is no longer 6, it's 9 to the right. So you have to write this as k minus 9. Both are correct. Feel free to put that in Desmos. I'm pretty sure you will get the same graph for both of them, and that too, both of them are going to match with the question as well. So these are the respective values of A, B, C, and D. Yeah. Okay, refer to the graph in H of H, T coordinate F and T coordinate of G. So they're talking about F and G, right? So let me clear this. Or let me, just focus on this. Okay, you know what, I'm just going to clear everything at this point. All right, now our focus is on F and G. This is T1 and T2. They are saying that which of the following is correct? Is H positive or negative? That's the first question. Obviously, H is positive. I mean, look at the Y values. Aren't these positive? The minimum value is just going to 30, which is way above the x-axis. So it has to be positive. It is positive. So negative or the question. Is the curve increasing or decreasing? Let's find out. I think decreasing, right? From F to G, it is descending, going down, right? So it has to decrease. So I will say option B is the correct choice, where H is positive and it is decreasing. And the last one says that describe how the rate of change of H is changing. So, okay, be careful about what they're asking. How rate of change is changing. They're asking the change of ROC. And the change of ROC is concavity. That's a fancy way of asking what is the concavity of this. And we can see that the yellow portion is down, concave down, right? So concave down means it is its ROC is actually decreasing. I'm going to say it is decreasing because ROC decreasing means concave down, and ROC increasing means it is concave up, right? But that's how this works. All right, so that's it. I think this was our last question. This FRQ is definitely resembles FRQ 3. So, but I hope the questions were helpful at least. The last few multiple choice questions were slightly tricky, of course, but you need to see all this, of course, to prepare for your AP Precal, and Unit 3 has a pretty decent contribution in the overall exam. So that's it from my side. Thank you for joining in. I'll make sure to publish this recording as well for whoever was not able to connect live with us. I'll probably put the download link of this mock as well. And that's about it. Stay tuned. There will be more mocks, probably full length as well going forward. So I will see you then. Take care. Bye-bye.